Assalamualaikum warahmatullahi wabarakatuh. We continue back our lesson on heat, on chapter heat. Okay, now we go to change of phase and latent heat of vaporization and latent heat of fusion. Okay, have a look at the change of phase first. Okay, phase transition. Okay, here, what is phase transition? Okay, phase transition occur whenever a material is changed from one phase to another phase. Okay, example, solid phase to liquid phase. That is phase transition. Okay, it involves certain amount of energy without changes its temperature. This is the important words. Without changes its temperature. During the two phase transitions, heat flow continues, but the temperature of the mixture of the two phases does not change. Okay, look at this what we call the diagram, phase diagram. We call it phase diagram. For example, ice. Okay, I give you the example. This is ice. Okay, ice. Okay, ice. Okay, with the initial temperature of minus 5 Celsius degree. Okay, this is below the freezing point. Ice inside the freezer, for example, is minus 5 Celsius degree. Okay, and then here there's okay, okay, again, okay, for example, ice, cube of ice. Okay, ice with the temperature of minus 5 Celsius degree, minus 5 Celsius degree. Okay, okay, you heat the ice. Okay, so until the final temperature of ice. Okay, until the you heat the ice, you give heat to the ice, which start with minus 5 Celsius degree, and then until the temperature of ice, the final temperature of ice is 110 Celsius degree. Okay, now I'm going to draw the phase diagram first, okay, to make you understand better. Okay, ice, we start with you heat the ice, which the initial temperature of the ice is minus 5 Celsius degree, and then you heat it until the temperature of the ice is 110 Celsius degree. Now look at the phase diagram here. I'm going to draw the phase diagram. Okay, so this is what we call the temperature. This is the temperature T, where the temperature is in Celsius, for example. Okay, this is T time. Okay, T, where here is in second, for example. Okay, I start with I label here minus 5. This is minus 5 Celsius degree. Just write minus 5, minus 5, and then here is 0, and then for example here is 100. Here 100 is here, 100, and then here is 110. Okay, let me draw the line first. Okay, so I start, okay, when you give heat to the ice, okay, it start to change the temperature from negative 5 to 0. Okay, negative 5 to 0. So from negative 5 to 0, the ice is still in solid form. Okay, ice, imagine ice at 0 Celsius degree is in solid form. It's still in solid form from negative 5 to 0. And then from 5 to 0, from 0, at 0 here, there is a plateau here, like this. Okay, there's a straight line here. And then, after a while, it starts to change the temperature from 0 to 100. And then again here, there is no increasing in temperature for a while. And then, from here, okay, again, it starts to change in temperature from 100 to 110. Okay, this is the phase diagram. So you can see here, you can calculate. Okay, you can calculate, for example, here, this is Q1, Q2, Q3, Q4, and here is Q5. Look at Q1. Q1 from minus 5 to 0. Here you can calculate the value of heat absorbed by the ice. You heat the ice, so heat is absorbed by the ice. Okay, so here you can calculate by using Q1 is equal to M ice, C ice, delta T. Okay, Q1. And then what about at Q3? Okay, what about Q2? Q2 first. There is no, okay, when you do this experiment and when you plot the graph, you can see that there is no change in temperature at this part. At this part, there is no change in temperature. Why there is no change in temperature? Why? It is because the heat that is absorbed by the ice is used to break the bond between to break the bond. Okay, it is in the form of solid. Okay, so the heat is absorbed to break the bond between the atom. That's why there is no increasing in temperature. Okay, at this part, this is here, it is in solid form. The ice is still in solid form. But for this part, at first here, at 0, first here is solid. And then here, there is a phase transition at this part. There is a phase transition. So here, it start to melt. So here is liquid. It start to melt. Okay, so there are two phases in this part. Okay, so for example, here I label here is A, then here is B, C, D, and E. So at part B, there is no increasing in temperature, and there are two phases here, which is solid and liquid. So heat is absorbed by the ice to change from solid to liquid. Okay, difference with this part, for example, part A, part C, and part E. At this part, at these three parts, heat is absorbed to increase the temperature because there is only one phase. So the heat, there is no heat needed to break the bond, but to increase the temperature of the substance. Okay, so the change in temperature here, okay, the change in phase here, we call it phase transition. So now, how you're going to calculate Q2? So Q1, you can calculate Q1. Okay, Q1 by using M ice, C ice, and then delta T. So delta T here is, I write the value. Okay, delta T here is 0 minus 5. So it becomes 0 plus 5. This is Q1 if you want to calculate Q1. And then if you want to calculate Q2, okay, Q2 from solid, from ice to water, here we call it latent heat of fusion. So kat sini adalah latent heat. So I write here latent heat of fusion. This part is latent heat of fusion. So latent heat of fusion, the equation is M ice LF. That means here is LF here is the latent heat of fusion of ice. Okay. And then we go to Q3. Okay, Q3. So for Q3, okay, the substance is in liquid form. And then Q4 again, Q4 here, look at here, there is no change in temperature. At part D here, there is no change in temperature. Again, the heat is absorbed to break the bond between the atom. It means heat is absorbed to change the phase from here, from liquid to gas here. Liquid to gas. Okay, there are two phases here. Okay, liquid here is, I write it is, this is water now. Okay, water. And then here is, okay, again, here is water, and here is ice. Right, this is ice. Okay, so at part B, there are two phases, which is ice and water. And then at part D, water and gas. And then part E here, the last part here is gas. The substance is, the whole here is gas. So if you want to find Q3, okay, Q3 is equal to still M ice, because the substance is ice. So the mass, okay, no matter it is in the form of ice or water, the mass is still the same. There is no loss of mass here. Okay, and then M ice, C water, and then delta T here is 100 minus 0. And then Q4, look at Q4. Q4 is latent heat of vaporization. Okay, so it is equal to M ice LV, latent heat of vaporization. Okay, and then Q5 here is, there is a change in temperature, so we will use this equation, M ice. C here is C, it is in the form of, okay, in this part, this is in the form of gas. So C here will be C gas. And then here is delta T. Delta T here is 110 minus 100. So therefore, the total heat required to heat the ice from -5 to 100 Celsius degree is equal to Q1 plus Q2 plus Q3 plus Q4 plus Q5. Okay, so you have to calculate 1, 2, 3, 4, 5. Okay, 5. This is the total heat required to change the ice from -5 Celsius degree to 110 Celsius degree. Okay, you cannot simply, okay, look at, when you get this equation, find the total heat required to heat the ice from -5 to 110. You cannot simply make like this. Q is equal to MC delta T, for example. So here you put, here is M ice, C ice, and then here is 110 minus 5. This is wrong. Banyak student yang buat macam ni. This is wrong. Okay, tak boleh straight macam ni awak nak cari total heat. Nak cari total heat, awak kena tengok dia ada latent heat of fusion ada tak. Okay, kena check. So kena buat heat, kita panggil ni phase diagram. Okay, so jangan sesekali buat macam ni, salah. Okay, okay, this is the example how you are going to calculate the total heat when it is involved latent heat. Okay, there are two types of latent heat of fusion and latent heat of vaporization. Okay. Okay, you can read this one, read it yourself, read the explanation yourself. Okay, And then look at the table 8.3. Okay, latent heat for some common substance at 1 atm and 20 Celsius degree. The temperature is 20 Celsius degree. So for the water, okay, kita ada water kat sini. Water 33.5 times 10 to the power of 4 joule per kg. This is latent heat of fusion. That means latent heat of fusion of water means here 33.5 times 10 to the power of 4. This is ice lah. Okay. Because this is latent heat of fusion. Fusion bahagian sini. Okay. So it start with ice lah. Latent heat of vaporization. Okay. Untuk water 22.6. Dekat bahagian sini lah awak akan letak nanti ni. Okay. The latent heat here. Okay, so when you calculate LV, for example for water, this LV here is 22.6 times 10 to the power of 5. Latent heat of fusion of water is 33.5 times 10 to the power of 4. This is the example. And the unit for latent heat is same with there is no, okay, look at the unit here. There is no change in temperature. Joule per kg and joule per Kelvin. Remember, the specific heat capacity is joule per kg per Kelvin. This is specific heat capacity. Alright, if heat capacity, the unit is joule per Kelvin. You don't have to mention about the mass. But for the latent heat, here, you can see here, you don't have to mention about the temperature. Okay, that is the difference of unit for that three things: specific heat capacity, and latent heat. Okay, have a look at the example of 8.3. Compute the amount of heat required to melt. Okay, M ice. You are given M ice is equal to 10 gram. So 10 times 10 to the power of minus 3 lah. Okay, kg. And its melting point is 0. Given the specific heat capacity at latent heat of fusion of ice. Dari sini. Okay. So this example is more to how you're going to use this equation, the latent heat equation. Q is equal to M LF. Okay, so if you want to heat, okay, if you want to find the total heat required to melt the ice, okay, for example, it is in the ice form. You want to melt this ice, totally melt this ice to become water. Okay, so here there is no change in temperature. There is no change in temperature. Why? Because it is we call it here, this condition we call it phase transition. There are two phases here, solid form, this is solid form, and then here is liquid form. So if you want to change from ice, okay, if you want the ice totally melt to water, okay, you need an amount of heat to change it, but there is no increasing in temperature because, okay, heat is absorbed to break the bond between the atom. Okay, so if you want to calculate the heat required, just use the latent heat of fusion equation. So M here is 10 times 10 to the power of minus 3, and then you are given the latent heat here is 330 times 10 to the power of 3. Don't forget 10 to the power of 3 because of kilojoule. Okay, so when you calculate, you will get 3.3 kilojoule. Okay, look at example 8.4. Okay, example 8.4. How long will it take for 900 watt, okay, heater to melt 400 gram of ice at minus 5 to 10 Celsius degree. So ice. Okay, ice. Start from 5 Celsius degree to 10 Celsius degree. Okay, you're given the value of latent heat of fusion of ice, specific heat capacity of water, and specific heat capacity of ice dibagi. Okay, here dia tanya how long will it take. So if you want to find how long means T lah, T. You are given the power. Okay, you're given the power. Remember, power is equal to remember before this you learn about you learn it in work, energy and power. Power is equal to work, the rate of doing work, or you can use power is equal to the energy, the rate of using energy. So energy, remember the definition of heat. It is about the flowing of energy, heat. Remember, heat is the flowing. Okay, you go back to the definition, the flowing of energy from high temperature to the low temperature. So look at here, look at the word energy here. Okay, so energy, so we can use this one. So we just change P is equal to Q over T. Okay, so we will use this equation. Okay, you are given the power. The question asks you about this one, T. How long, T. Okay, so to get T, okay, you have to find the value of Q first. Okay, and then now how you are going to find the value of Q. To find the value of Q, look at here, from minus 5 Celsius degree to 10 Celsius degree. Okay, you will use Q is equal to MC delta T. Okay, but you cannot simply do it like this. M ice, for example, M ice, C ice, delta T here is C ice. Delta T here, you just take 10 minus 5. Okay, this is wrong. Cannot like that. Because you can see here, there is an amount of ice which the temperature is minus 5. When there is minus 5 to 0, at 0 Celsius degree, there is a latent heat of fusion of ice. So you have to calculate. First, okay, the first step, you have to make a phase diagram. This is easier for you to make the equation, to write the equation, phase diagram. So look at the phase diagram of ice. Okay, draw the phase diagram of ice. The ice start from minus 5, right? So minus 5 is here. For example, here is minus 5. And then to 10 Celsius degree is here. Okay, so this is T. Okay, this is S. Okay, so it start from minus 5. Minus 5 to 0, there is an increasing in temperature, because it is in the form of solid, because there is only one phase, okay, which is solid form. So there is no change in phase here. Okay, at this point, ice start to melt. Okay, ice start to melt from here to here for a while, maybe how many seconds, several seconds. It start to melt. When it's totally melts here, the temperature will increase to 10. Okay, so you can see here, there is Q1, Q2, and Q3 here. So how you're going to calculate Q1? So Q1 is equal to M ice, C ice, and then here is delta T is 0 minus 5. This is Q1. Okay, and then Q2. Q2 is equal to M ice. Okay, and then here is latent heat of fusion of ice. And then Q3. Q3 is We still use MIs, which is you're given here is 400 gram. Okay, 400 gram. We use because it is the same substance but in the different form. Here is solid. Okay, here is solid. Here is liquid. It is in the form of liquid. This is solid. This is here is there are two faces here, and here is solid. Okay, so here Q3. So for Q3 is MIs. C here is sea water. Don't use sea ice because it is in the form of water at this part. Okay, here is 10 minus 0. So therefore, the total heat is equal to Q1 plus Q2 plus Q3. The total heat. Q1 plus Q2 and plus Q3. So when you calculate, you will get here, this is the answer, 153,000 joule. Okay, so therefore to calculate the time taken, okay, to heat the ice, okay, from minus 5 to 10 Celsius degree, by using P is equal to Q over T. So Q here is this one, Q total. P is 900 watt. So you can find T. Okay, understand? Okay. This is the important thing. You know how to calculate this one. Total heat. And then look at the example 8.5. Okay, the last example 8.5. Then after this you can do your tutorial. Compute the mass of water at 25 Celsius degree added to insulating cup containing 100 gram of ice cubes at 15 Celsius degree. That will result in a final temperature of 5 Celsius degree for the drink. Okay. Water, mass of water. Okay. For example here, mass of water. Ni water lah. Water lah. Ambil water. Okay, water. For example, water. The initial temperature of water is 25 Celsius degree. Okay. So there is a cup containing 100 gram of ice cube. Ni ada ice cube dalam ni. So ice cube lah. Okay lah ice cube dalam ni. Ice cube. Okay, ice cube lah. Okay lah ice cube dalam ni. Okay, ice cube ni, ice cube. Okay, so ice cube the initial temperature is minus 15 Celsius degree. You put this water, okay, you put some water inside the container, okay, inside a cup, okay, which contains ice with the initial temperature of the ice cube is minus 15. And you will get the final temperature after mix it. Okay, you will get the final temperature is 5 Celsius degree. This is according to the example here. Okay, 5 Celsius degree. This is the final temperature. So in this case, okay, again, for this case, for this question, example 8.4, there is no heat. You don't have to use heat gain is equal to negative heat loss because there is only one substance. For example 8.5, there are two substances. That means there are two systems. There are two systems. So this is the first system. This is the second system. There are two systems. You mix the first to second one. And then the system will reach the equilibrium temperature, which is called final temperature here. Okay, and the value is 5 Celsius degree. So now how you're going to calculate the mass of water? We don't know the mass of water here. What is the mass of water? You have to calculate it. you're given the mass of ice cube, okay, and then that one, okay, and then you're given the specific heat capacity of water, ice, and latent heat of fusion. So here there is heat gain and heat loss. So water will lose the heat, ice cube will gain the heat. Okay, so here we write the equation. Okay, heat gain is equal to negative heat loss. Sorry. Okay, so heat gain, ice gain the heat. Okay, ice gain the heat is start from, so look at ice start from minus 15. Okay, I draw the phase diagram first. Phase diagram here. For the ice, this is for the ice. This is for this system. Okay, ice start from minus 15. Minus 15 here. Okay, minus 15, and then this is the final temperature 5. And then there is a latent heat, and here is 5. So for the ice here, there are 3. Q1, Q2, and Q3. So here for the heat gain here, Q1 plus Q2 plus Q3. This is for heat gain only. And then heat loss is minus water, minus Q water. So Q1, let us do one by one. Q1 is M ice, C ice, delta T is 0, 0, minus 15. And then plus Q2. Q2 here is the latent heat of fusion. M ice, LF. And then plus Q3. Q3 here is still M ice. And then C water here because it is in the form of water. And then here is 5 minus 0. Is equal to minus M water, C water. And then final temperature here. Final temperature here is minus 5. Not minus 5. 5. Okay, 5. 5 minus the initial temperature of water is 25. Okay, look at this one. This is the way how you're going to make the equation by using this relation. Heat gain is equal to minus heat loss. Okay, look at this part. I want you to look at this part. This part. This one. This one is important. You cannot simply do that Q is equal, just use one equation. You use Q is equal to M ice, C ice, and then here is minus 5 minus 15. Cannot. This is wrong. Cannot. You cannot do like that. Okay, you have to use, you have to calculate for Q1, Q2, and Q3. Okay, hope you clear about this one. So from here, you calculate it yourself and try to get the mass of water. The question asks you about the mass of water. Okay, this is how you're going to use heat gain is equal to minus heat loss. This example and this concept is very important. Normally, you are asked about this one. Okay, you are tested about this one in your test. Dia tak tanya yang mudah-mudah, dia tanya yang macam ni soalan. Okay, so try to do as much as you can about the question about heat. Heat gain and heat gain is equal to negative heat loss. Okay, we stop here. Okay, finish about heat. Try to do your tutorial. Okay, any problem you can ask me. Okay, thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.